in construction, I think. For instance, you see a lot of bridges that are made from this kind of shape. And tunnels, all those type of things. If you throw a ball, it makes that kind of shape. So anything, motion, could be projected in that kind of way. So a basketball shot, a golf shot, some soccer shots, they all make that shape. And so it's quite a prevalent shape in the world we live in. So that's why it's kind of important that we look at it. And it always has this format. It's the something x squared plus something x plus a number c. It's always in that way. For instance, you could see you've just been looking at some like 9x squared plus 6x plus 1. That's an example. So a, b, and c are just numbers. We just don't know. So this is called the general form. Perhaps you came across this in year 9. Maybe, maybe not. Okay, so that's the general form of a quadratic equation. Looks like that. Now, if the x squared is actually a positive one, so a is a positive number, like most of the ones we'll be dealing with, it has this shape, happy face. And if x squared is positive, we make a happy face. And if x squared is negative, we make the sad face. So actually most projectile motions and stuff, when you throw a ball, that x squared is negative. A lot of equations you've been dealing with up until this have been such like x plus 7, or y is equal to x plus 7. You might have a y here. You can have a y here as well. What is the shape of this one? It's a straight line, yeah. It's a straight line. This one, curved. One turn. This one, no turns. This one, one turn. What about if y was x cubed plus? So we saw some of these when we did some multiplications earlier on. What's the shape of that one? That deals with this shape. 2 turns. So it's, think of, I don't know. Where does that occur in everyday life? 2 turns like that. Waves. Yeah, you can see it in waves, yeah. So, roads, yeah. Yeah, mountains, waves, roads. Also, you can see stuff like daylight or tides with the waves. So temperatures in the day, temperature rises during the day and comes down at night, and then rises during the day and comes down. So a lot of things follow that kind of shape. And then if we do y to the 4 or x to the 4, it forms another shape, which will have, instead of 2 turns, it might have 3 turns. Not all of them, but some of them have 3 turns. Okay, so we're trying to build up our skills with these different types of equations. You're pretty good at this one. Linear equations. Came up a lot in the last few years. You did coordinate geometry where you had 2 points. Oh, let's get the distance between here and here. What's the slope of this line? Oh, the rise over the run. You may remember doing stuff like that. But of course, the world around us is more curved than straight lines. There's more curves. And that's why this type of equations are first delve into the realm of the curved maths. So it is useful to be able to find the factors of any quadratic equation. We've looked at the special ones in the perfect square and the difference of 2 squares. But what about any quadratic equation that's not perfect? How do we go back and form those 2 factors that multiply to give it? We've got to have a strategy. When we had perfect squares a minute ago, we had something like x squared plus 6x plus 9. And that formed a perfect square of x, 3, 3, and plus, yeah? I think we had that a second ago. Because it multiplied out to give that. In other words, these 2 things multiplied to give that. Where did the x times x come from? Why do we think x and x? Because that's x squared. This also has an x squared, so I'm going to say this is also x times x. But where did the 3 times 3 come from? From the 9. 2 things that multiply to give 9. Now this was perfect. 3 times 3 gives 9. Now this time it can't be the same number times the same number.
So it has to add to minus 7 and times as well.
Exactly. So these 3 times 3 multiplied to give 9 and added to give 6. Do you see that? Multiplied to give that one, add to give that one. So now we're trying to do the puzzle. What multiplies to give 12 and adds or subtracts to give negative 7? Okay. 3 and 4, that's the place to go, yeah? Okay. But there's a negative here somewhere. So they both have to be negative? Why one negative, one positive?
Because if it was both negative, then the 7 would be a positive.
So where's the 7 formed from? Well, it's formed from the x times x gives x squared, x times negative 3 gives negative 3x, minus 4 times x gives minus 4x, and minus 4 times minus 3. It's just from these multiplications. Where does the 7 come from? These two put together. And they had to both be negative, because if one of them was plus, we wouldn't make 7, would it? It'd make 1x. So my idea is to always test this little multiplication to see, do I make the 7 in the middle? So this is correct. That is the correct factorization of the one above. What did we do? Well, we use a process of logic, really. 12 can either be 4 times 3, 6 times 2, or 12 times 1. Which one of those is most likely to add or subtract to get to 7, the middle term? Well, you picked 4 times 3 because that's, yeah, you know that gives 7. Okay? Let's pick another one here. Let's see, can we crack the code here? X squared minus 2x minus 15. We have a lot of options here for 15. Not a lot, I mean 2 options. We've either 1 times 15 or 3 times 5. Which one of them is most likely to make a 2? 3 and 5, yeah? Not 1 and 15, they're too far away from each other. They add to 16 and they subtract to 14. So let's draw my 2 brackets. Let's put 5 and 3 in. X times x still gives the x squared. What signs do they need to be? Leo? Okay, you've gone with the negative with the 5 and the positive with the 3. Why are you thinking that?
Because negative 5 plus 3 equals negative 2.
Yeah, negative 5 plus 3 makes negative 2. So if I had them the other way around, I'd make a positive 2. If this was positive, it would be winning. Another way I look at it, even before I put in the signs, I can go, right, I know that these two end up multiplying to give 3x, and I know these two end up multiplying to give 5x. And I need them to make minus 2x. So, the 5 has got to be the minus 1, and the 3 has got to be the plus 1. So the 3 is with the plus, and the 5 has to be minus to make a negative 2. This is the answer. The lines I've drawn underneath are just a check I do. All right, let's do another one. X squared plus x minus 6 is the one over there. Okay, 2 brackets. My first port of call. Draw 2 brackets. It always has to be, if it's just x squared, it always has to be just x times x. And then I think about 6. 6 and 1, 3 and 2. That's all I've got. Which one will I pick? 3 and 2. What signs will I go with? Is this correct? Sruni, is that correct? No? Why not? Because that will be a minus 3x and a plus 2, and I want to make plus 1x. So this will make minus. So if I swap them around, this makes plus 3x, this makes minus 2x, and that does give my 3x, take away 2x, it leaves me 1x, which I wanted. So this is correct. This is my answer, the factorized version. Are you ready to have a go? Kind of. Don't have much time left. We have a couple of minutes left. Here's a set. Let's see how many of them you can get. So write the equation, draw the 2 brackets. You know it's going to be x times x, and then you just look at the factors of the last number. So in this case, it was 12, 4, 3, whichever is going to make the middle term. It's like a puzzle. So write the question, draw the two brackets. You know it's going to be x times x at the